Here we are at the parking forest at PCC Sylvania in Lot 10 in southwest Portland, Oregon. Water is sheet flowing up from the parking lot about, I don't know, maybe second or third parking space over there. The sidewalk here, the landscape here, all of this driveway area and all of this parking area is all draining into this. And you can see that we ended up getting wheel stops that were solid. I really would have preferred more openings in the wheel stops, the newer versions, but we ran out of money, so this is what the college had and this is what we put in. So water comes along here and it'll concentrate in these openings, and then it works its way into the base, the 1/4 inch by 10 landscape rock. It's crushed. It's a crushed rock, so it's hopefully not going to move around too much, and down into the the amended native soil, basically compost and permatrix, and then it's going to. We hope that it's going to move out underneath either side of here, and that the entire 12-foot width is going to be accessible for the water to infiltrate down in, because we built this on clay soils that drain at about 1/2 inch to 1 inch per hour. And so when you're working in that kind of regime, you really need a larger area to infiltrate. You can't just pond it up or it won't be gone and ready for the next storm. Our overflow system now in like the next project that we do, where we're not grant driven and we don't have to monitor water quality or volumes of water coming out or anything like that, this would be the assembly here, and you can look at the overview video for more information on the parking forest assembly. But in our case, we needed to have water quality monitoring, and so we ended up and so this would be the assembly, and it would drain out sort of the lowest point here. And it would just continue on. You know, this used to all be parking lot, and it used to just sheet flow down here and sheet flow down there and just keep going down to a catch basin down there. Now it comes in, some of it goes into this trench, some of it overflows in really big storms, but I predict we're going to capture a whole bunch of water in here, especially now that the trees are going. Once the trees get their roots out, and the whole biology gets going, I have high hopes for it. And then, but once this whole trench, this 12-foot wide trench fills up with water, it'll just seep out the bottom and go down there where it used to go. But like I said, we have water quality monitoring requirements, and so we have this assembly of materials. There's a hidden perforated pipe down at the bottom of this trench. Water comes into the perforated pipe, comes into the catch basin here, and then to the catch basin is a connection to our overflow structure. So these are all solid pipes, our overflow structure. I tried to build a level spreader here, but it is really hard to build and so water would pond in here, this whole area, and then all along the same elevation, it would just, the idea is that it would just kind of cascade over this same grade. But of course, that's really hard to build with dirt. And we got a bit like 4.5 inches in a weekend, which the system really should be able to take, but it shortcut right here. And so today we put in some sluice sedges, some native sedges that are aggressive spreaders to help protect against erosion in the next couple of storms. So those will get established. They're going to take a little while to get established, and we might have some bark dust moving around again. But once these fill in, and you can see how we planted them in a really random pattern. So water comes out of this overflow structure here. You can see the grate here, and it ponds up. It ponds up and then goes out. And then I can just show you inside here is a spot for sampling a standing sample. So we have some standing water down there. I guess it's kind of hard to see, but there's some standing water in the bottom of that, and there's also a hobo to measure maximum water levels. So we're going to see what size storm causes an overflow. And we'll also be doing some water quality monitoring. The BES is helping us with that, and we have some various students here at PCC who are helping us with it too. So there's the hydrology of the parking forest.